So this is Gemar Corporal, and today I'll be having an online lab. I'll be having two experiments which are to measure, which are to characterize a thermocouple sensor as well as to design an orifice for a typical application. So first, we are going to do first the to characterize a temperature sensor, which is the thermocouple. We have here the theory, and we are going to click on the aim. So our aim is to understand the working principles of thermocouple. So how the thermocouple works and the different types of thermocouple we will understand. So objectives here, we have three objectives. You have to understand electrical effects, study static and dynamic characteristic of thermocouple, study effect of thermowell on thermocouple performance. So the aim of the thermocouple, if you don't know what is thermocouple, it is a device that senses the temperature and then convert the temperature into voltage. So we have here, click on the pre-test. We are having pre-test here. So we have 5 questions. We have to answer these 5 questions. So first question is, thermocouple is a sensor as well as it is a transducer. Temperature being sensed by negative temperature coefficient NTC type thermistor is linearly increasing. So its resistance will exponentially decrease with temperature, since this is an NTC thermistor. So the material used for thermistor construction is a semiconductor material. National Institute of Standard and Technology does not recommend this in temperature scale for NIST applications. I think it is Rankine. Usually Celsius is being used as well as Fahrenheit, because Fahrenheit can be converted directly to Celsius. Which of the following represents normal body temperature? So the average, the range of the normal body temperature should be between 36 to 37. So I think letter A, if we're going to try letter A, 310 minus 273.15, that the answer is 36.85. So I think letter A is the correct answer. And then we're going to click submit. So we have here the result, 5 out of 5. If you're going to view the solution, okay, they didn't have the exact solution of each question. They only have the right answer, but the letter of the correct answer. But if you want for further readings of each of the questions, why the answer is letter C, letter B, you can check it online, or you can click to my description on the description, my description box, and I'll be providing the link of each of these questions. So feel free to click the link. So we are now on the simulator. We'll be applying the procedures of the different experiments, since we will be having 2 experiments in this lab, in this thermocouple lab. So we'll directly go to the simulator, since we'll be applying also the procedures. So click in the simulator and click on the click here for simulator. So as we can see here, we have the level 1 static characteristic. This is just first the level 1, and then if we pass this level 1, we'll now move to level 2. So the first step we are going to do is to click on the drop-down list of the thermocouple. So we have here the different list of the thermocouple. We have the J-type, K-type, R-type, S-type, as well as T-type. So for in our case, we just click on the J-type, and we have after clicking the thermocouple type, selecting thermocouple type, we are now going to select the reference temperature. This reference temperature is the cold temperature. So in our case, we are going to select the 0 degrees Celsius. And after clicking that 0 degrees Celsius, now click the green get temperature green box. So the temperature will be this temperature is considered as a hot portion of the of our thermocouple. So the recorded hot portion of our thermocouple is 143 degrees Celsius. So using this value, we now click on the thermocouple reference table. So by clicking on the reference table, this link will directly provide you the reference. So since the type of thermocouple that we click is that J-type thermocouple, so we're going to click the J-type thermocouple. So you can choose any of the type of thermocouple. So if you chose the J-type, you just have to select the J-type thermocouple. So here we have in the first column we have the degree Celsius. Second is the reference. So for example, the value that we get is 143 degrees Celsius. So we have here, just click on the first column we have this is the temperature that we got. It's 140 degrees Celsius. So using this temperature, so it should be in between 140 and 150. So how can we get this value, the exact value of, since the temperature that we got is 143 degrees Celsius? So how can we get the value, exact value? So by using the interpolation, I think that you are all familiar with interpolation, since you are in your high level courses of engineering. So we have here it should be interpolation. So by interpolation, it should be 140 minus 143, 140 minus 150, 150 times the 7.4959 minus 8.010, 7.459. So if you ever wonder how did I get this value, you can click on I'll be providing link on the step-by-step interpolation. So if you are willing to learn how to interpolate easily, so you can click on the description box. I'll be providing the link there, and you'll be able to know the step-by-step process of interpolation. So the value that I got is 7.6686. So it can be round off into 7.669. So 7.69. Okay, 7.69. So after you enter the value, the value that you get after interpolation, so you're going to click submit. So if this value shows correct, the answer that you get is correct. So we'll be doing this try. So after submitting, you are going to click again the get temperature. So the temperature will be changed. So this is our new temperature. So 352. We now move again. Look in the provided link. So it is 352 degrees Celsius. It should be between 352. It should be between on the range of 350 to 360. So by interpolation again, we can get the exact value 350 minus 352. 352. So 352 over 350 minus 360 divided by 19.090 minus 19.642. 19.642 minus 19.090. So the value that I got is 19.20. So 19.20. Click submit. So it shows the correct answer, and this will be our last trial. So it's the new value that we get is 195 degrees Celsius. You can click the thermocouple reference table since we already clicked on that. So we now move to, it's 195. So 195, the temperature that we got, it's 195, should be on the 190 and 200. So 190 minus 195, but we're 190 minus 200 times 10.2 A, ano lang, A, alpha A minus alpha B minus alpha A. Our alpha A is 10.224, 10.224, tapos our B is 10.79. It's 10.50. It's 10.50. 10.50. Yeah, it is correct. So after 3 trials, the green the squares here, we have the level 2 plot. Next level will turn into green color, meaning that you unlock the level 2 and you unlock the plot as well as the next set. So we now look on the plot. So we have here the plot. As you can see, it is linear, but in reality, this is not a linear plot. So we, on our abscissa, we have the temperature, and our ordinate, we have the voltage. So this is the plot of the temperature that we get, or the 3 trials temperature. So click close, and we now unlock the level 2, which is the dynamics. So we're going to click on it. So we have here the level 2 dynamic characteristics. So we have here the step. We now click on the bear. So the time constant at 8 seconds, it shows here. So you have the thermocouple type. So J lang din yung type natin, since this is the type that we used on our previous lab. So second is to click this check the box. So we now select different materials. For example, we select SS304, and then we select the thickness 1 millimeter. So the time constant changed to 10.96 seconds. As we can then check this box for the thermowell, and then we can select different materials, as well as thickness and the filling material. For example, magnesium oxide silicon compound, we now select magnesium oxide. So as we can see, as we added thermowell and we chilled, the temperature, the time constant increases. So we can have the formula tab. We have here the formula, where X is the thickness, K is the thermal conductivity, and we have here the different materials for the different thermal conductivity for the different material thermocouple used. We have the J. It has the T type thermocouple has the highest thermal conductivity. So we can check on that. So you can check also the formula if you want to calculate. So you can have that. So the purpose here, kay we have the plot here of the different we added we have the bear, yung thermocouple lang, we added the windshield, and we added the thermowell. So as it increases its time constant, as we can see kay yung thermowell, as we added thermowell, kay dito na siya sa 80 plus. But yung wedge shield kay yung time constant niya is dito lang siya sa 50. So that's the differences on adding thermowell or yung bare na thermocouple lang siya, and then we added wedge shield, and then we added thermowell. As we are done with the simulator, we now move to the post test, which is here. So here we are, since we already know the types of thermocouple, its functions, and the compensation. Now we have here the post test after the simulator. So CJC stands for, that is cold junction compensation. It is a process of removing the voltage which was created in the cold junction, so by which will be discussed later. So lead wire compensation is necessary for the both RTDs and as well as thermocouples. For J-type thermocouple material are used, for J-type, we have the iron inconstantan, because the chromel constantan is at are materials used in the E-type thermocouple, and chromel and alumel are materials. These are metals used for the K-type thermocouple. Thermowell is used for protection of the sensing element. It is for the protection of the thermocouple, RTDs. So type thermocouple is used for cryogenic applications. So the type of thermocouple used for cryogenic applications is I think the type is type E thermocouple. Submit. Yeah, it is type E. So we have here the solutions. So if you are wondering the exact or the explanation of each of these questions, you can click the link I will be providing in the description box below. So feel free to click the link. So we now move to the last part, which is the review questions. This is a test of comprehension of state to explain the law of thermoelectricity. The law of thermoelectricity, we have the law of homogeneous material. We have three laws actually: law of homogeneous material, law of successive or temperature intermediate temperature, law of successive or intermediate metal. For the homogeneous material, this states that same metal cannot generate. For example, we are using since we know that thermocouple should be composed of two different metals to generate the electromotive forces. So by using these same metals, it cannot generate EMF. So second is, what is cold junction compensation, how it is achieved. Cold junction compensation is a process of compensating the voltage which was being the voltage which was being achieved or created created between the thermocouple and the attached wires. For example, if we're going, so the how can we achieve this compensation? We can achieve this by maintaining the temperature of the cold junction. For example, since we are just using cold bath, we don't know that the temperature, we can't say that the temperature is always 0 degrees Celsius. So by using compensation, we are maintaining the temperature 0 degrees Celsius on the cold junction. Explain for number 3, explain the criteria of selection of thermocouples. So for selection of the thermocouples, the thermocouples, it should be dependent on their function. What type of thermocouple you are going to use. So for example, you are for high sensitive, sensitive na mga materials, so you should have used this type of thermocouple which are sensitive. So explain the advantages and disadvantages of thermocouple. So one of the advantages of thermocouple is that thermocouples are very inexpensive. Ibig sabihin they are less expensive than RTDs, as well as for the thermosets. Now, thermosters. So it also measures the widest temperature ranges. For example, the RTDs have it measures lowest temperature ranges, but the thermocouple measures the widest temperature ranges. And their advantages is that the output voltage is very low, as well as it demonstrates non-linearity, and the last is it needs compensation, di ba? Yung cold junction compensation need pa natin dito. So for number 5, what are different types of thermocouples based on material used for constructions? There are different types of thermocouples. We have the J-type thermocouple, we have the E-type thermocouple, which is used in the cryogenic use. We have also the B-type thermocouple. The B-type thermocouple consists of three metals. Tapos we have also the K-type thermocouple. So I think it differs. The use of different types of thermocouple differs on saan mo siya gamitin, where are you going to use this type of thermocouple. So I think that would be all. Thank you and God bless.